Okay, we're going to talk about, this is lecture number 5. We're going to start talk about chapter 13 and chapter 14 together on inheritance and polymorphism. My objective today is try to go over the most straightforward, simple case in inheritance and polymorphism, and such that you can start using this simple, but this is in fact the most commonly used construct to model and to represent the concept of inheritance and polymorphism in C++. Okay. So we talk about this picture, that this picture represents how do we want to solve a problem in a real complicated system. How do we use object-oriented paradigm to model the actor, to model the concept, to model the abstraction in the unit, what we call classes. And then from these classes, we use a variety of way to implement, and then we will be able to run it. So this is the whole picture we have been emphasizing. So today we're going to really emphasize on how do we define classes. So you already know how to define one single class. I think you already know, for example, what's public, what's private, what's constructor, what's member function, even what's static member variable in a class. So you see that the class could be really powerful to model complicated system through a small unit of classes. So we're going to follow that paradigm to see how we can leverage the new construct I'm going to teach you today, which is inheritance. And inheritance also involves another interesting behavior called polymorphism that comes with the idea of inheritance. So I was started to show you a very simple example about how inheritance works. This is, in fact, the example coming from chapter 13 of our textbook. It's about the relationship between two different classes. One is called box, one is for carton. All right. So you can see in this example, we have two classes. The top is class box. And the class box has all the member variable and member function that we talk about in chapter 11 and 12. This, by now, you should be really familiar with the class box. All right. However, now there's different keywords we're using in the top picture. Instead of using private and public, now we're using protected. Okay. Protected is a specific keyword that is used in C++ to represent a inheritance relationship, which I will show you the difference later. Okay, so now in the top, you still have that class box, and you have protected, you have a public. In the public, yeah, you see you have constructor. Your constructor, this is probably a copy constructor that input all the variable. This is not a copy constructor. This is just a user-defined constructor. Sorry, I kind of said it wrong there. That's on the top. That's a class box. On the same side, that we have another class called class carton. And now you see that how we define class carton is that instead of specify all the detail about class carton, after the class name carton, I put a colon, and then I put public box. Okay, I will explain about what is that public, the keyword public means, but this is basically saying that carton is a box. Okay, this is in English. Just carton is a box. That is a inheritance. So sometimes you will hear people to say inheritance or class hierarchy, class inheritance. But the other word to say about the relationship between these two classes is called is a relationship. Is a relationship. So for example, in this case, carton is a box. So when we express this concept in C++, then the inheritance relationship between class carton and class box has taken place over here. Okay, so let's take a look at the definition of class carton. So by the word inheritance, so everything that you have from class box will be automatically being included in the class carton. On top of that, you can add some new variable. So here there is a variable called material. And material is a new variable which doesn't have in the class box. Okay, we don't have that in class box, we have that. So we're doing some sort of specialization. We make a carton a special kind of box, even though we're following the rest of the box interface and implementation from the outside. But inside, now we introduce a new variable. So of course, with carton, that we have a new constructor we need to provide, and then we have maybe some new variable, new member function we need to introduce, but I didn't include here. You can see that this is just a segment of code I copy from the book, so we can actually show you the most important concept. So over here, we have two classes. Class box and class carton, using that column public box, that particular segment of code to link these two classes of code together. Okay, so in this picture, there is one more thing I want to explain, which is the constructor. So we talk a lot about constructor in the lecture number 4. So now here is a more complicated constructor here, is that when I construct a carton, in fact, I'm not just construct the carton itself. In some sense, because these two classes are being inherited together, so I'm actually going to also have the constructor for the box being called. So essentially, you can think about the sequence is that when I want to create an object for class carton, the first thing is that I'm going to actually call the constructor of class box and to construct a class box. And then on top of that, I'm actually going to do other things I need to do specifically for the constructor for the carton. Okay, so that's the relationship. So that's why you can see here what I'm calling when carton take 1, 2, 3, 4 attribute. The first 3 attributes were included after that column in the red. It says box, LV, WV, and HV. Those represent the length, width, and height to a class box. So that call box is going to call the constructor in the parent class of class box. And then after you've done that, then you try to initialize the variable called material. So that's the order. That's not only the calling sequence, but that's the order you should make it to happen. Okay? All right. So this shows you a very simple example that you can use only change a few things in this picture. So there's 3 things actually you need to worry about in this picture. Let me summarize. Number 1, you need to change for the parent class, the class box that will be inherited by some other child class. You have to change some part of that into protected. If you don't change that to protected, then those parts cannot be inherited. Okay, so the protected is a new keyword such that you want to allow certain variable for the derived class to be able to, in this case, the derived class is carton. And for example, if you put length, width, and height, you make those become not protected. You didn't put it into the protected area, then basically your class carton will not be able to access the variable directly. And if you have some kind of access function to allow you to access through public, then it's no difference between other class and the class carton. So you need to change that to protected if you want your class carton be able to access to those three variables directly. Okay, this is number one. Number two, to specify the relationship between carton and the box, that you need to put a colon, and then you use the keyword public, but I will explain to you, you don't have to put public there. You can put something else there. And then you can put the name of the class you're inheriting from. And that brings the other class, which is class box, into this picture of class carton. The third thing you need to worry about in writing inheritance program in C++ is that regarding the constructor. When you call the constructor, you need to also make sure you call the constructor for the class that you are inheriting from as well, because you need to provide the right argument in order for things to happen correctly. So if you take care of those three things, congratulations, you can actually start writing inheritance program in C++. Okay, so let me just generalize this slide a little bit. So what we talk about, usually the terminology that we call, this is a relationship between what we call a base class and derived class. And then the inheritance is just a relationship. Say the derived class is actually base class. All right. So for example, carton is a box. And having this together, then you basically, if you can find out anything that is useful as your base class, then you can use this construct to basically just inherit the code. And then you will be able to build your own class on top of what has already been built. All right. Right. So for example, this is a picture that you have many different classes. They're inheriting from each other. For example, at the root of the tree is called community members. And community member could be employee, student, or alumni, and then the employee could be faculty and staff, the faculty could be administrator, or it could be a teacher. And then you could have some role who is doing, like in UC Davis, some of our faculty members are doing both administration and the teaching together. So you could have this hierarchy of classes, and the root, which is the base class, is community member. And you can define employee as a derived class from the community member. On the other hand, the employee could be a base class for another direct class called faculty, or another class called staff. So once you draw this diagram, then you know, okay, I can have a really, really complicated class hierarchy to represent all the important concepts I want to represent. And then it's clearly to me that this clear to you that how these classes are supposed to relate to each other. Okay, so this is what we have been talking about. We talk about base class. We talk about derived class. We talk about is a relationship. And there are two perspectives about inheritance you should be aware of, because both perspectives are actually very important for you to do the job right in developing a really good object-oriented system with the right kind of inheritance relationship. So first one you should be careful is that when you use this is a relationship is representing the really how the class should be abstractively seen together. So in the previous example, I show you the community member and the faculty and the teacher and the student. When you saw that, you actually see conceptually how I can see the whole system based on the understanding about the class hierarchy. And this is very important. I mentioned to you in the first lecture, when you design the object-oriented system, you have to make it something very natural. Because when you make something natural, it's actually going to be close to the real complicated system. I mean, if your modeling about that class hierarchy is not reflecting what's happening in the complex system you try to model or try to build application to help, to support, then it will be really hard for you to match the incorrect class hierarchy into the problem that you want to solve. And you will encounter that this is not right, that's not right. So this actually based on the experience. So what I want to emphasize at this time is that inheritance is a useful tool, but use it right. And use it to represent really the relationship you really should capture. And naturally, that's actually something is very important for you to, the first step for you to do successful object-oriented modeling and system building. Okay, that's the first message I want to tell you. Capture the right relationship. The second one you want to do is, this is more related to software development. So I put down the word OOSD, it stands for Object-Oriented Software Development. So essentially, when I inherit the class definition from the software development point of view, I'm actually reusing something that has been developed before. So that potentially saved me a lot of time in developing that piece of code and also the testing process associated with that concept. So therefore, if the model is clear that this is the right way to define the class hierarchy, this also lead to reusability about the concept, the code, then we can actually make it a lot faster to develop the code to solve more problems. And this also deals with extensibility. For example, between box and carbon box. So with carbon, initially we only thought about box, so we don't think that the class carbon is really necessary, is really useful. But don't worry, if we later realize in our application, we realize we really need to have that extra attribute called material to be included in the class definition. So instead of modify the class box, I actually just derive from class box, have a very clear new class called class carton. And then I will be able to do that. So in some sense, for object-oriented software development, that the mechanism of inheritance is great for both reusability and extensibility. Okay, so the concept of inheritance, especially in its language construct in C++, there's a lot of detail we need to worry about. For example, I provide a link here, and if you go to the top link, it basically say all the secret, all the important detail that is not so trivial about inheritance, and that particular page basically collect all the interesting cases there. So I don't want to go there, at least not right now, because I don't think you need to use all of that. But my objectives is for you to be able to start writing inheritance program in C++, and gradually you will see that whether you need certain thing, and then gradually you can check a website such as this website that collecting all the what they call strange inheritance in C++, and which will tell you more detail precisely about the linguistics about inheritance. But I'm going to talk about three things, and I want to address these three things in this lecture. So this is the most basic fundamental for chapter 13 and chapter 14. So the first one is, well, how do we define a derived class? and also how do we create objects from this derived class. Okay, that's the one thing. You define, you create. So that's step number one. You need to know how to do that. All right, that's my objectives. And number two is how do you relate yourself as a derived class to the parent class, to the base class? Because even though conceptually you just copy everything from the parent class to the derived class, but in some sense not. In some sense, there is still a separation. Sometimes it looks like they're independent. Your parents and the base and the derived, they're independent. But sometimes the derived class need to access some of the variable in the base class. And how would that relate to each other? And we have to look at that. And the third thing is that, well, because we have a class hierarchy and you have object being created in variety of places in this class hierarchy that due to the inheritance relationship. And how do we actually interface with that? In particular, right now, I'm going to show you the idea of a polymorphism. And how do you actually come up with the most simple kind of polymorphism called virtual function in C++, and such that you can interface with object that actually, even though it's the same object, it will move up and down from this class hierarchy. So just in this example, when you create an object, you create a carton. But in fact, you're not just create a carton, you also create a box, because those are together being created. Okay. So let's actually try to go over the three things so you can start to build your own program. Okay, the first one, I'm going to talk about how do you actually create a class. So I already show you the code, but this is using a diagram to represent the relationship between class box and class carton. So the top is class box that you have three variable, and the bottom you have class carton, you have a one variable. And it's very important for you to know, I mentioned to you, is that when you create an object, when you define the class, you're using this column public box, then you inherit from the base class. But when you want to call, I mentioned that you first have to call the constructor of the base. Okay, the purple line, call the base. And after you finish calling the constructor, means that the base class is already settled down, has been initialized correctly, anything you want to do in the base class. And then you actually go down to call the constructor in the derived class. Okay, that's the order when you create a class. But also when you talk about creating a new class, new object from the class, that sometimes you need to think about destructor as well when you want to delete the object. So it's reverse order. When you want to delete the object, you first call the destructor of the derived, and then you will call the destructor for the base. All right, that's the idea. And okay, once you create it, now you can see that you can actually access the interface of both base and the derived class. For example, in the base, now I have a 4 different member function. In the derived, I have a 2-member function. And now you can actually call them as if they are 2 separate projects. So in some sense, when you create an object for carton, you really create 2 objects. One is an instance from the class box, one is the instance from class carton. And then you can still using their individual interface or public interface to actually access to that. And that's, once you use inheritance, you have the flexibility to use those objects. Okay. Now let's look at the second thing. Now I'm actually talking about the protected. So what do I mean by protected? So protected in some sense is that there are some variable that I like the derived class to be able to access directly. So now let's look at the parent class. The parent class has three sections: private, protected, public. So in the public, regardless you have inheritance, everybody can access, right? So private, on the other hand, is only this particular parent class or base class they can access. Nobody else can access because they can only access the public. That's the principle of encapsulation. You try to protect the inside. Okay, now we're seeing that, well, if somebody inheriting from me, I will think that that particular class should have some privilege in accessing something which is different from the public. And therefore, I have something called protected. So you can see that if this is, the parent class still put it in the private, then basically when you write any code in the derived class, you won't be able to access directly. You can only access to those private through the public interface of the parent, of the base class. Okay. On the other hand, you can put certain things in the protected area as well. Whenever you put protected, the the derived class, now they can actually write code to access to everything. So in some sense, everybody else can still access the green part, which is a public. But now because you have that inheritance relationship, now you can directly access the purple area, which is the protected area. Okay, so that's the second part. I mean, how do you interface between base class and derived class, and somehow you can have some special privilege through this keyword called protected. Okay, so remember at the beginning I said in the example of a carton and box, we say class carton colon, and then we say public, and then we say box. Okay, that particular syntax, the word public in front of box is what we put down here. It's called the mode of the inheritance. So basically, any inheritance relationship is going to be class, derived class, class name, colon, and that's the mode of inheritance, and then it's the class name of the base class. Okay, so that mode could be, in the example we saw earlier, is public, but it could be also, you can put protected there, or you can put private there. So public, protected, private is saying that whatever you got from your base class, where are you going to put it in the derived class itself? So for example, in this picture I show, if you decide to be public, then anything in the protected, so I use the sky blue character represent whatever it has in the base class. So whatever in the base class it says protected is going to be protected in the derived class. Whatever in the public class in the base class is going to be a public class. It's going to be public region in the derived class. Okay, so that's if you define as public. Most of the inheritance, they mostly use public because that's the most common way of using inheritance. On the other hand, the other two are also possible. You can actually say protected. What do I mean by say protected? It means that whether it's protected in the base class or is public in the base class, they both will be put under the protected area of the derived class. And similar, if you define that as private, which means that both protected and the public is going to put in the private section of the derived class. So this is essentially saying that, okay, now you allow me to inherit from you from both the protected region and the public region, but where I'm going to put it in my own derived class is using this inheritance mode to control. Okay, so that's the second thing I would like you to know about inheritance in C++. Okay, The third thing I'm going to show you, this is a bit tricky. Now we're going to talk a little bit about polymorphism. So when we define a relationship between base class and derived class, we're going to think about, you're going to think about yourself as an object. In fact, it's very interesting when you do object-oriented modeling. Everything is an object. Yourself as an object. So think about yourself as an object, and you inherit a lot of things from your title, your biological inheritance, your social cultural inheritance. There is a lot of inheritance which is formed about me as a person. So you think about that, then you come back to think about the question I posted here will be quite interesting. So number one, who are you really? I mean, because you have two identity, at least in this very simple. In fact, in real world, we have lots of identity. But in just this simple example, we actually have a two identity. One identity is associated with a base class. We are a member of base class because of that inheritance relationship. But we also is a member of the derived class. So we are simultaneously represent ourselves as a member of two different group of people. And the thing is that it's interesting, it's not as simple as saying that, okay, when we are in the context of the base class, we'll just behave like every single base object. And if we're in the context of derived class, then we'll just behave like a derived class. That works sometimes, but that might not work in a lot of situations as well. I mean, for example, we're all members of UC Davis. And but I'm also a teacher, and you're a student. And when we consider community member at UC Davis, I'm going to behave differently, even though I'm still considered as a community member. But because I have a association with me as a teacher, I have some responsibility I need to contribute differently than a member who is later being a derived class of a student. So that is the simplest form of polymorphism, because you all things looks like you're from one single class, which is from base class. But depending on who you really are, that you're going to behave differently. And that's conceptually very useful concept. In fact, that is a very natural concept in our society, how we interact with each other. And sometimes we feel that concept could be good, but sometimes it could get into trouble. We'll see some of the interesting example later. But you got my point, is that there is a concept called polymorphism already happening in this world. And what we are trying to do here is that, well, how do we first, number one, how do we actually see the difference? How do we actually be able to implement this kind of concept of polymorphism in the programming language like a C++? Okay. All right. So I'm going to show you an example to now to see all three things. I'm going to tell you three things. One is, how do you create this object? How do you use this object? How do you see the protected variable? And how do you actually implement polymorphism using one single program, which is derived from your homework assignment number 2. Okay, so now we're going to look at class transaction. So I changed the class transaction a little bit from the transaction.h you have. In fact, this is going to be the basis for your homework assignment number 3. So I now have a 3 section of class transaction. I have a private, I have a protected, I have a public. And what I still have transaction count, which is a static variable. I still have that. Now I have a private, has a transaction type, is a private. Transaction description is a private. And transaction status, those 3 things, I think I don't want my inherited class to derived class to change that. And also the timestamp, when this transaction was created, those 4 variables, I still put it inside the private. and also together with that static variable, but static variable is belong to the class, not even to the object transaction. Okay, so I have, you can see that now I put a few things as private. All right, so now I have something which is protected. So now in my mind, I changed the design a little bit. Instead of directly thinking about like somebody flying airplane or take a trip, I'm actually thinking about agent, the agent who helped me to process this transaction. So every transaction should have a person responsible for this transaction. So that's why you have transaction TR agent as a person. And this agent is the one who is responsible to create and to manage this transaction. Okay? And also I want to say where this person is. Is this person in Davis, or this person in New York, or this person is in somewhere in other place? So I need to know a person as well as the, oh, sorry. Doesn't mean where the person is. This means that where this person initiate and create this transaction. Okay, so that is the location where this transaction happened. All right, and then IP address, because it's a location, it's using internet, so I want to record the IP address. And the other variable, which is the generic, I call void star, which I already explained to some of you in homework assignment number 2. It's a placeholder for data that could be override with others. So this is void star is just a generic pointer. And at this moment, don't worry about that. I'm not going to tell you about what TR data is going to be used, because we'll see that later. Okay, so we have the private area with a protected area, and again we have a public area. Based on that definition, now I have the constructor. I only listed one here, which is the constructor with all this variable. So now I'm using this bracket initialization format, and such that I just initialize, I put every variable into, every argument from the constructor into the variable, corresponding variable. And I have this two function, just like homework assignment number 2, set data and get data. And this part is interesting. I define another member function called GetDescription. And this GetDescription is essentially getting the description about this transaction, but you saw that I actually put a virtual in front of that, which means that this particular function, GetDescription, is a virtual function. Okay, that is just the definition of a class transaction. I haven't tell you how that will work. Now we see the next slide, which we actually see another derived class called flight. So I define class flight colon public. So I'm actually inheriting as a public mode for this inheritance, which is the most common one, by the way. And public transaction, so it means the flight is a transaction. Okay, so now you in your mind you have this picture. Your base class is transaction. Your derived class is flight. Okay. So now I have, of course, I have some private and public, and I didn't have any protected. I mean, later, if I realize I need to have even more derived class from the flight, then I might need to consider to add protected. But now let's just assume we only have 2 to make things simpler. Okay, under the private, you can see I have 3 extra variable I added to that. Number 1 is the static variable, which is just like what we did transaction count. Now I have a flight count. And I have passenger, because every flight need to have a passenger. It's not the agent who help you to book it. It's the passenger who is really going to be flying with this transaction. Okay, so there is a passenger as a person. And also it has an airline that it will go with it. Okay. And there is another variable, which I actually put it in the public right now, is called ticket number. So because a flight, you must have an airline, you must have a ticket number. And together with the airline and ticket number and the passenger, you will be able to pull out all the information from that airline company, such as distance and other things. And okay, so now you see that how we can relate this class flight with class transaction. And now we look at the constructor. So the constructor, we have a flight, and the flight take all this parameter, including the type, description, agent, where, source IP, when, passenger, and airline, and the ticket number. And you can see that now the first constructor I'm going to call is calling that transaction constructor. That's why after the constructor, after the column is transaction. And inside that transaction, I'm using bracket initialization and put in all 1, 2, 3, 4, 5, 6, or 6 arguments into that constructor, which will invoke the constructor in the parent class. All right. So after that is done, then I'm initialize my own variable, including passenger, airline, and the ticket number. Okay. So we have that done over there. All right. All right. So then we have a function called GetDistance. So this fly is actually going to have an implementation called GetDistance. And in some sense, I just want to show you an example that by doing inheritance, I separate some of the functionality or abstraction out of a more general class, like a transaction, into a more specific class. So if you look at the homework assignment number 2, I kind of almost mingle these two classes together, and transaction become a almost design associated with the concept of distance. But now by this separation, now the concept transaction is cleaner and is more useful that I can build this base class transaction to support other type of transaction which might not involve any distance. So that is a trick for you to think about how do I represent that class hierarchy that I can cleanly model exactly what's the boundary in the real life. Okay. All right, that's the constructor example. You can see that, okay, now you can call both constructor at the same time. All right, so now I'm going to tell you one thing about the protected. Remember I said, if you go back to the previous slide, the protected region, which is including the transaction agent, the agent who is help you to book this transaction. So that is protected, which means that I can directly access to that object, right? So now I have a function which is very useful. I define under class flight, which is a derived class, which is called conflict of interest. So this function, what we're actually trying to do here to implement is that assuming this is some airline's policy or FAA's policy, is saying that the agent who booked the flight for a passenger, which if the agent is also the passenger, and we consider this is potential a conflict of interest, and therefore this need to be raised an alarm for other people to check into that. So we're not saying that this cannot be done, but this is something which we like to be able to check. So how do we actually implement this? Because the flight passenger, which is the class person, the person flight FL underscore passenger, is an attribute that's actually being defined in the derived class. While the agent is also under class person, that it is a variable member being defined in the base class. So in some sense, we are comparing a base class member with a derived class member using, in this case, is overloading operator, equal. which in the implementation, you probably already know for your homework assignment number 2, that will just compare whether their VSID are the same. If they're the same, they're the same person. Okay, so that's the definition. So in some sense that we cannot do this. If you don't put that TR agent in the base class as a protected member of the base class, then the compiler will say, hey, you cannot do this because this violates the protocol. Okay, so that's the second thing you should know. Okay, now we finally get to virtual function. So we have that virtual function also here, get description. So you remember when I look at the base class transaction, I have that virtual function for get description. And now I have a virtual function get description. So you see there is a difference between the implementation of get description. In the previous slide, the get description will print out the value of the TR description variable. So in the base class, they do have such a variable called TR description. But over here, the get description function inside the class flight is actually saying that just return flying. Okay, so it's a different way of implementation of that same concept. So one is class flight and one is class transaction. They each have their own version of get destruction. Okay, so now we have to see that why is that keyword virtual? What will that do to the semantic meaning between the class transaction and class flight? Okay, what is the meaning with that? Okay, so let me ask you a question. If I give you a object reference, and this object reference is a reference to a class transaction, then when I call get description, what do you think the get description will get back for you? Do you think this get description will get back to you about that TR description variable that they have in the class definition, or it will give you this string called flying? If, assuming I just give you the information that this is a reference or a pointer to an object that belongs to the class transaction. So normally, if you think about that, the compiler wouldn't know. The compiler normally wouldn't know. He will just think about, okay, this is a class transaction, and therefore I can only assume that this is a class transaction, and therefore I will only invoke the member function that match the type of the class or of the object. So it's just like if we all consider as a community member, regardless you're a teacher or you're a student, then basically when I treat you as a community member, I assume you have only one behavior. That is called monotone behavior. Instead of having a what we call polymorphism, which we would like to change that such that the system will really try to find out what the true type that person or that object really is, and maybe you will invoke the flying. In this case, let me quickly describe the difference. I will show you an example in the next slide. But if I don't have the virtual, if you remove this virtual from class transaction, remove the virtual from class flight, then essentially if the object is a transaction, you will actually print the TR description. If the object is class flight, you will actually print out flying, because I just take whatever type is a very strong type there. However, if you put both virtual, then essentially there's a trick I can play. In fact, I will tell you how this can be implemented. In fact, this is not being resolved at the compiler time. Is in the runtime. It can be because compiler doesn't know when they look at the code. Will be resolved in the runtime environment to implement the virtual function. But now you don't need to worry about that implementation detail. You just know whenever I set virtual, that when you execute the program, it's going to see what is the true type about this object. So in that class hierarchy, where you go down to the leaf of that class hierarchy, the original class, which is the bottom of the tree or that hierarchy, and whether that particular class has a declaration of virtual function like what we have here. And you will invoke that even though you were declared as a community member. So when you create an object that you created as a flight, but you can actually casting it or move some part of that such that you looks like you belong to the member of the base gallery, which you are. That's why I said that is really true that when you use inheritance, you are both the base and you are the derived. And now you could sometimes represent you're part of the base, sometimes you can represent part of the derived, but how do you control that? Using virtual function. So now let's see the next slide. I want to show you that, okay, after I define those 2 pages, I'm going to run this piece of code, which is a little bit similar to your homework assignment number 2, part 2. So I create 2 person. One is Lion King, one is Nemo. And I create one transaction F1. Okay, transaction 1 is nothing to do with the ticket number or airline. It's just F1. It's just a transaction. And then I have a flight F2, which is a flight. I create 2 flight F2 and flight F3. And just be careful for flight F3, the agent and the passenger are the same person. So therefore, if I use the button of the code says that F3.conflict of interest, it will actually give you the Boolean variable will give you a true value because those 2 overloading operator comparison will reveal they're the same person. Okay. All right. So now I'm actually going to show you the middle 3 lines of cout code here. Okay. So I'm actually going to print the description. And of course, if you do fly 1, get description, fly 1, sorry, it should be F1 because I changed the code here. Okay, fly 1 is F1 corresponding to the top part. Okay, because I was using fly 1, but then I cannot fit into the statement, so I actually changed fly 1 to F1. Okay. So fly 1 dot get description, and because fly 1 F1 is a transaction, and it is created as a transaction object. So the first line you will get the fly 1 description will actually give you the description of DESC. That's as being provided in the transaction F1. Okay, so we go to fly. The next statement, it says fly 2 dot get description. Fly 2 dot description, you can see that I'm actually using the flight. Of course, I'm calling my own get description. So the second statement will also give you flying. Okay, not give you description because this fly 2 is being created as an object flight. Okay, that's the second line. But the most interesting thing I hope you will learn is the third line. So you can see that I take the fly 2. I take that fly 2, which is the type is class flight. But I casting it with transaction. So when I do this casting, I actually pulled out the transaction part of the fly object out of the fly. So essentially now you see it's a transaction object instead of a fly object when I do that casting. So that is very interesting. I told you that who you really are, by using casting, you can actually split yourself, saying that, hey, this part is representing this particular type of me outside of myself. So that's kind of convenient using casting. Okay, so now the whole thing about casted by the transaction casting for the fly 2, now that part become a transaction object. We still call it F2, but it's a transaction object now. So the transaction object, now when I call get description, now this part is tricky, that the virtual function is going to make a difference. That if it's not being defined by virtual function, then your get description will just print the regular transaction object printing about get description. But because I already defined the get description is a virtual function, and I also know the runtime system, not the compiler, the runtime system actually know that it's tracking the object and realize the original class that this fly2 was created was actually fly2. And therefore, it will call the class flies version of get description, which means that the second line and the third line will print exactly the same thing, regardless how you're casting it. Okay, so you should really think about this concept, and then how can you actually write the program to do that. Okay, so so this is go back to the picture I showed you. I said, who are you really when you're under inheritance? You have a multiple view. You have a multiple view. You have a view about base class. You have a view about derived class. And sometimes that gives you some power for you to declare your polymorphic behavior using the virtual function as I show you. So virtual function, its concept is not hard. Its implementation could be very interesting for learn, which is quite challenging later. You will get to that. But the idea is really help you to be able to let the derived class, when you do this casting, when you represent the different kind of interface to one of your parent class, you can still let it behave differently based on which really the lowest level of a derived class that's actually being used to create this particular object. And that concept is very useful because this is essentially represent the question I posted here is that do you means the object. Do you want to be seen or treated as a pure base or as a derived? If you want to treat it as a pure base, don't use virtual function. If you want to treat it as a derived, then you need to use virtual function. So that's your power for you to decide. Okay. Okay, so we went through this, for this lecture, we went through the basic about inheritance and polymorphism. We cover how you can define an inheritance relationship and how do you call the constructor in order to do things. And also we share with you about the particular keyword called protected. Under protected, a derived class can access to some element in the parent class, which I show you in the example of when I compare a conflict of interest between the agent who help you with a transaction and the passenger who really take the flight. Okay, that also tell you that how it's important to do object-oriented modeling. You can separate the functionality about the abstraction between transaction and the fly, and such that it will be cleaner for the modeling perspective. And the third thing, I talk about polymorphism, which really is important about how you interface with not just individual class of object, but interface with a whole class hierarchy. Because when you create an object under the scope of the global class hierarchy, and what do you want to behave? What do you want other objects to see you as a member of what? And that mechanism called virtual function is going to help you to develop that. Okay? So now is the time for you to use this tools that you have to write your own program and see how it will work. Okay? All right, good luck. See you tomorrow.